This is the important question. This is the question that, in my opinion, is really the very first grade 12 question, because it's a much more realistic version of this question here. See, the problem with this question is, if you're cutting the grass with a lawnmower, you don't have an applied force that's directly forward in the direction of the ground. What, you're going to get down on your hands and knees and you're going to pull the lawnmower forward with your teeth and a rope attached? Of course not. You're going to do this. We use elevated handles. We use forces that are not horizontal forces. It makes things easier. You want to stand upright and push this lawnmower along. But the lawnmower is only a foot off the ground. So how does the question change? Because if you notice, the numbers that are going to be used in this question match the previous question. The lawnmower is still 40 kilograms. It's being pushed from rest with a force, and it's the same force as the previous question, 197.6 newtons. But the difference now is that force is here, 197.6 newtons, an applied force down the handle. It's being applied at a 25-degree angle above the ground. And there's a coefficient, same as the previous question, between the lawnmower and the ground of 0.3. So the resulting acceleration for the previous question was 2 meters per second squared. Let's see how this question changes. See, the difference is you're not pushing the lawnmower forward with an applied force of 197.6. It's on an angle. So the very first thing you do in this question, or in any question in this course where you see an angle in the question, is you break that angle into components. So although it is 197.6, you're pushing down the handle. We want this. We want to know what is the vertical and the horizontal component that made up that 197.6 newtons. So you've got a right angle triangle in here and a 25-degree angle. You split it up into the two sides the same as before. 197.6 sine of the angle is going to be across from it, and 197.6 cos of the angle, 25 degrees, will be beside it. So let me do those two calculations off camera here. 197.6 sine of 25 degrees, that's 83.51. I'm going to write that right here, 83.51 newtons. And 197.6 cos of 25 degrees. The forward push is only 179.09 newtons. And now we can ignore that original force value and the angle. There is no more angle. It's now those two components. So that's the very first thing you need to do to this question, these so-called lawnmower type questions. Split it into components. Now there's something very, very, very important still coming, but I'm going to wait for a moment to get there. Okay, so now the idea is, this is the applied force pushing the lawnmower forward, and friction is going to hold it back. So we need to work out friction. And if you remember from grade 11, the friction formula will not change ever, even in grade 12. Force of friction is coefficient multiplied by normal force. You need that normal force. And if you remember in grade 11, to even get the normal force, you first had to start with the force of gravity. So let's begin there. Let's figure out this. What is the force of gravity on this lawnmower? And actually, you already did it in the previous question because the numbers haven't changed. Force of gravity, and notice how I wrote a little lowercase g there just to indicate what type of force it is mg. And if it's a 40 kilogram lawnmower being accelerated with Earth's gravitational pull, 9.8 meters per second squared, or newtons per kilogram, 49 newtons. Oh, I'm sorry, why did I say 49? Scratch that, I don't know what I was thinking there. 392 newtons. Now, Please listen carefully, because this is the gist. This is the important part here. In grade 11, if you worked out a force of gravity of 392, the normal force pointing up in the air, the ground supporting the lawnmower, was 392. That is not true anymore. Here's the problem. When we split this force into components, yes, you determined that the actual forward applied force is 179.09, but here's the difference. There's still this downward component. You are forcing the lawnmower into the ground by pushing it forward on an angle. You are pushing the lawnmower into the ground at 83.51 newtons. The normal force is not always equal to gravity. The normal force has to be what it has to be to balance everything else out. In grade 11, the problem was the only other force we ever had to consider was gravity straight down. So whatever the value of gravity was, that ended up being the same amount of force that the ground had to force up. But here, there are two downward forces. Gravity is pulling the lawnmower down, or forcing it down at 392, and you're pushing it into the ground with another 83.51. Remember, there's no formula for normal force. That still hasn't changed. You're supposed to look at this diagram and say, I push it into the ground, and it's being accelerated due to gravity. I need to add these up. The ground has to push up, not with 392, because that won't be enough. There's not 392 newtons of force down. There's 392, and there's another 83.51. There's 475.51 newtons of force in the downward direction. And that's what the ground has to push back with. So this is the main change. This right here is the most important part about this entire question, that the normal force changes. So we still had to work out force of gravity, because without working out force of gravity, you wouldn't know what the normal force has become. But now, when you do friction, there's actually going to be more friction than there was before, because you're not just pushing the lawnmower forward, you're forcing it into the ground. So now the friction will be different than the previous question. The coefficient of friction is still 0.3, but the normal force is increased to 475.51 newtons. Sorry for my messy handwriting here, but multiply those and you have a new force of friction, 142.65 newtons. So what this question now really works down to is this. You've got, oh sorry, I thought this was a lot lighter. You've got this forward applied force that I was supposed to highlight in orange, but look at it. You got that forward applied force and you have friction holding it back. And really now those are the only two important forces. You can almost redraw the question to simplify it, and you can say this. I'm pushing the lawnmower forward with an applied force of 179.09, and friction is holding the lawnmower back with a force of 142.65. The net force, in other words, what's the overall force when you consider these, is the subtraction between them, the difference between them. I would write a formula out, but just because this is an example on camera, I'm just going to subtract them off to the side. 179.09 minus 142.65. Actually, I changed my mind. I do want to write it out because I want you to have good format here. You're looking for the net force. There is no formula for net force. You make a net force formula based on what you see in a diagram like this. My net force is going to be the applied force forward minus friction, because friction is backward. So I've got 179.09 newtons forward. I'm going to subtract off 142.65 newtons, and that gives an overall 36.44 newtons total for the net force. And then finally, If you're looking for acceleration, it's the rearrangement of Newton's second law. Acceleration is always net force divided by mass. And really that's it. This is the only calculation that is really the important calculation for getting the answer, is make sure you do net force divided by mass. But to get the net force, you got to go through all this. So now that we have finally arrived at the net force of 36.44 newtons, you just need to divide by the mass of the lawnmower, which was 40 kilograms. So the acceleration previously was 2 meters per second squared. Now it comes out to 0.9 meters per second squared. There's more friction because you're forcing the lawnmower into the ground by pushing down on it. And even though you don't feel like you're pushing down on it, the fact that you're pushing it on an angle that goes down means some of that downward push results in forcing the lawnmower into the ground. And yet it's still easier. So this is the final answer to the question, I think. Yeah, what's the resulting acceleration of the lawnmower? So there's our final answer to the question. And I don't want you to memorize the solution on this sheet, because let me go back and show you one quick thing. What if you pulled up on the handle instead? I mean, most of you cut the grass. You turn around at some point, and instead of pushing on the lawnmower handle, you do this. You turn around backwards and you pull the lawnmower. You pull it forward across the grass. That's going to change this question around entirely. Well, not entirely. It's not going to make the entire question new. But when you break up a vector that is pointing up in the air like that, you're pulling the lawnmower forward, but here's the weird part. You're lifting up on the lawnmower this time. You're lifting. So even though gravity's straight down, you're already lifting up on the lawnmower with a little bit of force. And that's going to change the normal force yet again. Because, well, I'm going to leave it up to you to discover how you do this question when you actually do that question on the homework. So we've got 4 questions on a page, and I don't even want you to look at question 43. Save that for, don't scratch it out, but save that for extra practice. I want you to do question 42, number 2, and number 4. Sorry, I cut and pasted them from other sources. Question number 4 is going to be the main one. And I want some intuition here. I don't want you to just blatantly copy out an answer. There goes the lights again. I want you to do question 4, and I want you to pay attention to this right here. A gardener pulls up on the handle of a lawnmower. Sorry, you probably can't see that. When you read the question, it's just like the example we just did, but the vector on an angle is going to be diagonally angled upwards. And that's going to change the normal force, as usual, because the normal force always changes in these questions because of the pushing and pulling of handles. But you won't be forcing the lawnmower into the ground. You'll actually be lifting up on it a little bit. And I want you to think carefully as you do the question about how that's going to affect the normal force. Question 2 is just like example number 1 in the previous video, but you have to draw it out first. Be careful, make sure you draw it accurately, or you're not going to get the right answer simply because you drew it wrong. And question 42, the first one, is totally a grade 11 question, a complete grade 11 review question that is a question like this. You have an object, it's sliding forward across the ground. There's no forward force. Sorry, I drew it like this, but there's no forward force. It's sliding on its own with some speed. And there's friction backwards, dragging it to a rest. And the question is, how far forward will it slide? Try that question. If you don't feel like you reviewed grade 11 enough to do question 42, start with number 2. Draw a careful diagram for question 2, split the vectors up, and answer it the same way we did example number 1. Do question 4. Remember this big star. Be very, very careful on what you do with the normal force. We're going to take these questions up, but like I said, you don't want to look at solution sets in the beginning. You want to try it the way you think it should be done and see what you're going to do wrong. And I will have fully written solutions posted for these questions so that you can follow through and check your own work.